Great. Okay. Well, I mean, I guess, Rob, you almost said it all. So I should say. Oh, okay. First of all, I'm Tobias Frøslev, and I'm from the Global Biodiversity Information Facility Secretariat in Copenhagen. I'm Danish also, but the Global Secretariat just so happens to be where I live also. And I have my colleague Thomas with me. He's up there. He's doing a bit more of the coding. I'm more like getting some ideas and thinking some thoughts, and then we carry it out together. So yeah, thanks for the invitation, Rob. It's really nice to be here, and it's super interesting to hear so many very interesting talks on method development and applications of eDNA. I have been a researcher myself until half a year ago, where I joined the Secretariat in Copenhagen. I've been working with various aspects of environmental DNA, and so it's really nice to be back, so to speak, and see all this enthusiasm and great data being produced. And I'm hoping to convince you, if Robert didn't already do that, to think about sharing that data in a more sort of operable way, where you're actually detecting species somewhere in time and place, and that data usually gets lost with it gets into a publication or something, but it's not really finding its way out into repositories where all other observations of species are gathered and are operable for reuse and research and policy making. So I hope by the end of the day here I have convinced you that you should share your data in GBIF also. Okay. Oh. So, but let's reiterate, what is GBIF? It's an IGO, an intergovernmental organization. It started 23 years ago from a wish from the OECD to have somewhere where all the biodiversity data could be standardized and collected and made available for reuse and policy making. So, and it's a free and open platform that anybody can use. The idea of GBIF is that to make this data, biodiversity data, free and open for everybody to use, but also we wish to ensure that the data is maximally standardized, so that you don't need to do a lot of extra steps when you go and access the data on the GBIF platform. Here are some few stats. So you see that right now there are more than 80,000 data sets. We have what are important here. We have more than 2 billion occurrences. What is an occurrence? That's a GBIF language for a detection of a species some place in time and space. So a dot on a map, basically, with a name on it. We have more than 160 billion records downloaded per month. That's quite a lot. And you see we have so far more than 8,000 peer-reviewed research papers based on data downloaded from GBIF. So the data that goes into GBIF is actually used for a lot of extra research, you can say. And you might think that your data, but it's just a tiny drop in the ocean, yeah, but it's actually a big drop, because many of your data sets probably contain thousands of detections in them, right? Okay, so this is the participation countries in GBIF. You see there's a little bit of a weight on the Western or the rich countries, or whatever we should call it. But we're growing year by year with more participating countries. So these are the countries that fund GBIF by an annual payment to running the costs of GBIF. And this is a map of publishing institutions. So that also shows that we actually do get a lot of data from countries that are not members of GBIF. So it's not mandatory to be a member to get your data in. Anybody can get data in. It's just the countries that are paying. We saw on the map before. So I have this slide here, or actually 4 slides coming up, showing a little bit of the data flow, you can say. Originally, a lot of the data that went into GBIF was museal data, collections and things being digitized from natural history museums. And then later on, citizen science and things like that has come on board with a lot of data from things like eBird and iNaturalist. And also, as you say, but not a lot, but from companies and environmental agencies, they also produce a lot of data. Some of them get the data in, but still not a lot, unfortunately. And the types of data is specimens, observations, literature. I mean, we actually also have some data providers that digitize old literature sources and convert that into occurrence data and feed that into GBIF. And it's all being standardized and provided with open licensing for free use by our nodes and other, the whole GBIF network. There are several instances of those offices and whatever around the world where data is converted into a standardized format where we can ingest it into the database. This is the center here where we have something called an IPT. It's short for Integrated Publishing Tool, I think. It's the repository, you could say, or repositories. We have several installations of those around the world where somebody operates those. It's just a piece of software that standardizes the data and puts a data archive on a server that we can then crawl with our machinery. And if a change has been happening in the dataset or a new dataset has been added, then we ingest that into the big database. So we actually don't have any data as such in GBIF in the central part, but we continuously pull from these data sources, leaving the updating and quality checking, etc., to those that provide the data. I won't go into details here, but you can ask if you want. So this is the last part of you could say the data flow is where the data then gets reused for research or policy making. We have a lot of other users than just researchers. We have IUCN and you can see IPBES, etc. up here using data from GBIF to base their evaluations of red list species and whatever on. So it's really important that we get all good data into GBIF. This is putting the puzzle together. Okay. So why should you publish your eDNA data to GBIF? I tried to list some arguments here. I guess I've said most of it already, but your data will be reused for research and policy making. I think that's important enough in itself. You all have some funding, you get some money, you produce really nice data, you make a nice publication, you get some credit for that, etc. But actually, all those really nice species detections, they could serve an even better and permanent purpose by finding their way into GBIF, where they will be in a continuous context of everything else on GBIF, and that's super valuable, not only for GBIF and research and policymakers, but actually also for you, because it's we have this literature tracking system, which means that every time your data gets used, you actually get a citation. We track that, so you can at any time go in and see your data set, how many peer-reviewed publication has it been used in. You can actually also take a little bit of code snips and put in your online CV or whatever, and then you can continuously show how many further research publications your data has been used for. And it actually also provides an additional route for discovering your data. Some of the data I have put into GBIF, I can't say for sure, but I believe that the underlying scientific paper has gotten way more citations because people were actually able to discover my data set in GBIF and go to the publication. I don't know for sure, but there is a tendency, it seems, that if your data is there, more people will find your publication. Your data set will be assigned a DOI, a digital object identifier. So if you're really proactive and get your data set to GBIF before you submit your publication, you can have that under your data availability statement. And people will see this data set also as an interoperable thing on GBIF. This was something I stole from, let's see if I can remember their names, Mariana, Brooke and Lauren, I think, poster yesterday, showing that only about half of the studies they looked at actually had the raw data deposited in some sort of archive, could be eDNA, a short read archive, or something like that. So even there, already there, the raw data, which is actually should be mandatory to deposit somewhere, is actually not always done, right? I also have papers saying data available from first author on something, and it's 20 years ago I wrote that. No way that data is alive. It's dead somewhere. Sorry. Yeah. So this is just a view on the rising number of peer-reviewed publications using GBIF data. This is the data set I was talking about, my first data set that went into GBIF. It was actually the first eDNA data set 5 years ago that Thomas up here contacted me and said, we're actually trying to get this eDNA thing rolling in GBIF. Can I use one of your data sets? We put it in, and as you can see, when I took this screenshot, it had 31 citations. But Wednesday we can look more sort of interactively at how you can browse stuff in GBIF. I won't go into that now, but this is just a data set view of something. Then a few years later, or was it before, I don't know, Thomas also asked me if I could help him build a blast tool, basically. So we have these 3 markers, ITS, CO1 and 16S, where we use 3 externally curated databases. So that is the GTDB, the Genome Taxonomy Database for the 16S, the Unite for the fungi, and then we have CO1, that is bold, we use there. And then we have built a sequence matching tool that is actually quite efficient and fast. So if you want to try that out, go to the website. This is a publication, I will speed up a little now. This is a publication showing that only one in 44 papers published in Environmental DNA journal actually had the data published to a biodiversity database like GBIF, which is of course a disaster. So how can you publish your data to GBIF? I think I'll skip this here, and then I'll point to the last one here with metabarcoding data. You can exploit our friendliness right here and right now. We have a special offer that you just give us your data and we'll get it into GBIF. Otherwise, we have this recently published update on our guide to publishing DNA-derived data. You can find it on the website. And then I think I'll leave a lot of this to the workshop if you want to participate there, and then I'll skip ahead here and show this is a tool we are developing now that makes it easier to get OTU table-like data into GBIF. It's Thomas doing the work here. It's a web-based thing. You can drag your OTU table and additional site metadata files here. And then you can also assign taxonomy using our sequence matching tool if you want to do that. You can also provide your own taxonomy. And then you can do a little bit of data validation, I would call it here. And then then you have an archive that can go to GBIF. You cannot publish it directly yourself, but this tool is still only in our hands, and how it will be deployed, we don't really know, but it's working, and that's what we're gonna use. If you give us your data, then we can also sort of stress test the system and see if we did it right. If you have to take anything home from here, then take a photo of this. These are QR codes to the central things that I want you to know about. The gbif.org/DNA is a portal to what we have of resources in GBIF. There is this invitation to share your eDNA metabarcoding data. That's what I'm talking about now. If you want to read about it before you send the data, you can go and read a little bit there. There is the link to the updated guide. There is a link to the webinar that Chris Meyer kindly promoted yesterday. It's a 2-hour recording and some extra material for eDNA and GBIF. And then there's a call for, if you are working with soil DNA metabarcoding, there is a call for data papers, which is a way of repaying your article processing charge. You get a scientific publication along with your data, so it's also gives you sort of scientific credit in the good old way of a publication. Thank you.